Hello, my name is KUNAL VERMA and I am here to demonstrate the burglar alarm that I have created on TinkerCAD. This alarm can be deployed in a car or at your home entrance. It constitutes of a PIR sensor, which is passive infrared sensor, which detects motion in front of it. This one is ultrasonic distance sensor, which calculates the distance of any object within its range. And this is the force sensor, which detects the force applied on it up to a certain extent, which is 10 newtons over here. And this is the tilt sensor, which detects the tilting when it is rotated past a minimum degrees of rotation. Now I will proceed further and demonstrate the alarm by simulating it. Here the green light over here is always lit unless it detects the motion in the PIR sensor. It will go on blinking. This yellow light is off unless there is an obstacle within 250 centimeters. On crossing the 250 centimeter threshold, it will just light up, and if there is an obstacle within 100 to 200 centimeters like this, it will start blinking with the rate of 0.5 seconds. And then if we have any obstacle within 100 centimeters of radius, it will start off blinking rapidly with an even higher refresh rate of 0.1 seconds. Now for this blue light over here, we have this force sensor. If there is a force beyond 0.5 newtons on it, it will just light up, and if there is a force within 2.5 newtons to 5 newtons, it will start blinking with a refresh rate of 0.5 seconds. And if we go beyond the 5 newton threshold, it will start blinking with an even higher refresh rate of 0.1 seconds. Now here we have the tilt sensor, which will make the alarm go off. Now if we have an obstacle within 100 centimeter for the ultrasonic distance sensor and a force above 5 newtons, then the alarm will go off with the lower speaker tone and the vibration motor will start. We also have a main switch over here for the whole system. Which when turned off will make this light red, which indicates that this whole system is turned off and inactive. But when it is turned on, the light will turn green, indicating that the system is deployed, the alarm is deployed. And now I'll try to explain the logics and expressions I have used in framing the blocks and framing the block code of my project one by one. And here's the block code for the green light. The green light is connected to the digital pin 7, and the PIR sensor corresponding to it is connected to the digital pin 13. So whenever the PIR sensor detects motion in front of it, sends a digital signal 1, and the green light, which was initially lit because the pin 7 was set to high, will now start blinking by these set of logics. It will start blinking by a refresh rate of 0.5 seconds. Moving to the yellow light, which is connected to the digital pin 6, corresponding to the ultrasonic sensor, which is connected to the digital pin 12. If the data received by the digital pin 12 I have named it as a variable dist and the corresponding logic to it. If it detects a distance greater than 250 centimeter, then it will not glow, but if the distance detected is within 200 to 250 centimeters, it will just light up. If the distance is within 100 to 200 centimeter, it will start blinking with 0.5 seconds refresh rate, and if it is less than 100, then it will start blinking more rapidly. Now moving on to the blue light, which is connected to the digital pin 5, and the force sensor corresponding to the blue light is connected to the analog pin A0. It is an analog sensor. The force sensor sends analog signals unlike the other sensors we have deployed, and the reading is I have created a variable force which is equal to the reading obtained from the force sensor. If the force is less than reading of 100, then the light will not glow, it will stay off. But if the reading is within 100 to 250, then it will just glow up. If the reading is within 250 to 350, then it will start blinking. And if it is over 350, which corresponds to 5 Newton, if the force is above 5 Newton, then it will start blinking with an even higher rate. Coming to the red light portion, which is connected to the digital pin 4, and the red light corresponds to the signal received from the tilt sensor which is connected to the digital pin 11. This sensor can be installed on the doorknob, so it can detect the tilting of the doorknob. When it is completely tilted to here, it sends a signal 1. If it does not send a signal, then the light will stay off, but if it is tilted, it will send a signal 1, which will set these series of events into action, symbolizing that the alarm has went off. Now for the level 1 of alert, the normal alert, we have if the distance of any obstacle is within 100 centimeters and the force applied, the reading of the force sensor is greater than 350, then the alarm will go off, the vibration motor will start, and the speaker will play with a lower tone. But if the alert, while the high alert, which will be triggered when the tilt sensor detects a full deflection, then the speaker will start playing with a higher tone. These are the corresponding current readings for each of the LED. Each of them have 19.5 milliamperes current passing through them, while this piezo speaker has a 3.81 milliampere current consumption, and the vibration motor has a 28.6 milliampere current consumption. Also, the link to this design is in the description below. You can copy and tinker it. My name is Kunal Verma. Thank you for watching.